Okay. Hey, if your degree is larger in the denominator than it is in the numerator, please remember that the contribution here, we talked about this a bit yesterday, but when you're dealing with an extremely big number for x, say like 1,000,000, we'd have 1,000,000 over 1,000,000,000,000. So this plus 3 is going to be insignificant. Okay? And as is the minus 9. Okay, so the contribution you get from this fractional part here, when you're dealing with an asymptote, you'd have 1,000,000 over 1,000,000,000, which is extremely close to 0. So the contribution you get from that fraction is a 0. Okay, same thing here. You have 1,000,000 over 1,000,000,000. So from the fractional part, the contribution you get is 0, but then you add 2 to it. So your horizontal asymptote would actually be at 2. Whereas here, it's again 1,000,000 over 1,000,000,000. The contribution from the fraction is 0, and you subtract 3, your horizontal asymptote's at -3. Y equals -3. And that's what this is summarizing down here. Okay, you get an extremely small number plus 0. You get an extremely small number plus 2. And you get an extremely small number minus 3. Okay, those are where your horizontal asymptotes are. When you're dealing with, if your degree is larger in the denominator. If you switch that up, and we say the degree is the same. Okay, so when we compare the degree in the numerator and the denominator here, if we ignore the a term there, x squared divided by x squared, that gives you 1. Right? So once again, if this was 1,000,000 and this is 1,000,000 or 1,000,000,000, okay, I guess 1,000,000 squared is 1,000,000,000, and that's going to be insignificant. This actually is going to be insignificant. Okay, you're still going to be really close to 1. So the contribution you get from this part is 1, with the exception of you have this 2 here. So rather than 1,000,000,000,000 divided by 1,000,000,000,000, you get 2,000,000,000,000 divided by 1,000,000,000,000. So 2,000,000,000,000 divided by 1,000,000,000,000 is actually 2. All right, so we get 2 here. So the contribution from this fraction is going to be 2. So that leading coefficient there, that number became a big deal right there. It changed it from 1 to 2. Okay, so we get 2 over 1. 2 divided by the 1 in front of the x squared, plus nothing on the outside to get an asymptote of 2. Versus here, once again, we ignore these things. They're not going to be significant. We're dealing with those really big numbers. You have your x squared, your 1x squared, divided by your 3x squared. That's 1,000,000,000,000 divided by 3,000,000,000,000. 1,000,000,000,000 divided by 3,000,000,000,000 is?
1/3.
1/3. So this is a third. So our asymptote is 1/3 plus nothing on the outside. So we get a 1/3. Leading coefficients here are
3 and 4.
4/3.
Nice.
So the asymptote is 4/3. We're not adding anything out here, so it's 4/3 plus 0, or 4/3. And here the horizontal asymptote, what is it?
5.
Yeah, 5 divided by 1. So we get, from the fraction, we get 5. We get a contribution of 5, and we add 3. So the horizontal asymptote's at 8. Okay, raise your hand. Maddie.
Are those other numbers always going to be insignificant?
They're always going to be insignificant when you're dealing with such big numbers, right? So when we deal with x being 1,000,000, that's 1,000,000,000,000 minus 2,000,000. Well, when you're dealing in trillions, millions are insignificant, which seems kind of weird. I wouldn't mind 1,000,000. Just saying. Just in case anyone's ever given it away, let me know.
Alright, I got you. I know a guy. Who doesn't
Well,
have-
hey, that's a good question. What if you're not dealing with millions? But remember, asymptotes are what your value, your asymptotes are when your graph, your function is approaching extremely big or extremely small numbers. Okay? So that's why we're dealing with those values. They're we're dealing with those big numbers because those are the ones that are significant when we're talking about asymptotes. They're what you're approaching. Okay? If the degree in your numerator is bigger than the degree in your denominator, and this is what we got to last night, a few of you got to it on number 17, right? You get your x squared and your x, so now you have 1 trillion divided by 1,000,000. Once again, this part's insignificant. However, that doesn't help us with an asymptote. I mean, when you go 1 trillion divided by 1,000,000, you're not going to have an asymptote up there at 1 million, right? We're not going to have that. So what we're doing here to find out what that asymptote is we do polynomial long division. So we take this and we divide it by that. And that's what we're doing right here. When you divide that out and do the math, you get x plus 5 and a remainder of 12. And that remainder, or we put here, plus 12 over x minus 2. And this part up here is equivalent to this function. So we have, and we're going to rearrange it, we're going to put the 12 over x minus 2 first, and then plus our x plus 5. So we're looking at it, our h term, our vertical asymptote, still at x equals 2. Our horizontal asymptotes no longer are horizontal. Our k term back here is actually a linear equation. So k is equal to y equals x plus 5. And so that linear equation becomes your oblique or your slant asymptote. Okay? So you got to graph that line. Any questions on that? Okay. So, let's take a look at the back. This kind of summarizes all asymptotes. In general, the procedure for finding asymptotes is the following. Okay, when we're dealing with our x asymptotes, okay, our vertical, set the denominator equal to 0 and solve. The zeros are discontinuities. They're either vertical asymptotes or holes. Remember, holes are removable. They're things we cancel out. When we cancel something out of the numerator and the denominator, for instance, if you want to give yourself an example here, you say you have y equals x plus 2 over x minus 2, x plus 2. And we cancel this piece and this piece out. Whatever made that 0, so x equaling negative 2, that is a hole. It's been removed. It's a removable discontinuity. Okay, what do you have on top? 1. So our new function would be 1 over x minus 2. Okay, with a hole at negative 2. And this would be our vertical asymptote at x equals 2. Okay? Are the degrees the same or different? On top and bottom?
Same.
You have,
No, different. They're different.
on top, we start out with a linear, right?
Yep.
On bottom, what do we start out with?
Quadratic.
Yeah.
Yeah.
It's a quadratic. Okay, so we have higher degree on the bottom, which means, what's the horizontal asymptote?
It's a slant. No.
Higher degree, so you have
Other one.
small divided by really big. What's that close to?
0.
0. So your horizontal's at 0. So that's what we're practicing today, right? All right. Anytime there are 2 vertical asymptotes, keep in mind there will be 3 different pieces to our graph. Okay? All right. Thanks. And then for your horizontal asymptotes, these are your y equals. Okay? And we just summarized that. I'm not going to read through it again. Okay. Very good? Okay. So, go ahead and take your assignment. Let's take a look at it.